Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from integrals. And in this class, we are going to evaluate this integral with the help of the concept of beta and gamma functions, right? So here we have to evaluate this integral that is from minus infinity to infinity, and the integrand is x square divided by a cube of 3x square plus 1, and we have dx, right? So let us call this integral as I. And here first of all I will apply an important property of definite integrals, which says that if we have an integral that is from minus a to plus a, and we have the integrand f of x and dx, then if this function f of x is an even function, then we can write this integral as 2 times the integral from 0 to a f of x dx. So this is an important property of definite integrals, where we can simplify this integral minus a to a fx dx is equal to 2 times integral from 0 to a f of x dx, provided f of x is an even function, right? And in case of odd function, this integral reduces to 0, right? So even function is defined as f of minus x is equal to f of x, right? So here if we compare this integral with this one, then the limits are from minus a to a, that is minus infinity to infinity. For a we have infinity, and the function or the integrand f of x is x square over 3x square plus 1 cube, right? And this function is an even function, which we can see easily by replacing x by minus x. So f of minus x is given by minus x square, and here we have 3 times minus x square plus 1, and here we have cube. So minus x square is a positive x square, and here also we have positive x square, so this is 3x square plus 1 cube, and this is our function f of x. So we have seen that f of minus x is equal to f of x, so this function is an even function, right? So now this integral I can now be written as 2 times the integral from 0 to infinity, that is 0 to a, and f of x is x square over 3x square plus 1 cube, right? And now we'll apply the method of substitution. So let us substitute here t is equal to 3x square, so that using this substitution we can reduce this integral into the beta function, that is beta m comma n is given by the integral 0 to infinity t raised to m minus 1 over 1 plus t raised to m plus n dt, right? So the beta function is defined by this integral where m and n are greater than 0. So using this substitution will reduce this integral into this form. So now we can write x square is equal to t over 3. So x is square root of t over square root of 3. So let us differentiate x with respect to t. So dx over dt is equal to 1 over root 3, and the derivative of square root of t. So we have 1 over root 3, and the derivative of square root of t with respect to t is 1 over 2 times square root of t. So now we have dx over dt is equal to this expression. So now dx can be written as 1 over 2 root 3, and we have dt over square root of t. Now here the limits of integration vary from 0 to infinity. So when x is equal to 0, which is the lower limit, so the value of t can be obtained from this relation. So we have 3 times 0 square, that is 0. And when x tends to infinity, then t also tends to infinity, because here we have 3 times infinity square, that is also tending to infinity, right? So now we can write this integral I as 0 to infinity. The limits remains the same, that is 0 to infinity and 0 to infinity. For x square, we can write t over 3, and here we have 3x square is equal to t, so we have t plus 1 cube, and dt is replaced, dx is replaced by 1 over 2 root 3, and dt over square root of t. So now let us simplify it. So we have I is equal to this 2 and this 2 get cancelled. So we can now write 1 over 3 root 3 outside the integral. So we have 1 over 3 root 3. Then we have 0 to infinity. Then here we have t raised to 1. And here we have t raised to half. And taking t raised to half to the numerator, we can apply the laws of exponent. So this is t raised to 1 minus half, and here we have 1 plus t cube, and this is dt. So we have 1 over 3 root 3, 0 to infinity, and t raised to half, 1 minus half is half, and 1 plus t raised to 3 dt. So now let us compare this integral with this one, right? So here we have t raised to half, and here we have m minus 1. So let us write m minus 1 is equal to half, and here we have 3, and here m plus n is equal to 3, right? So we can now find out the values of m and n. So m is given by half plus 1, that is 3 by 2, and n is given by 3 minus m, that is 3 minus 3 by 2, that is 3 by 2, right? So now we can write the integral I as 0 to infinity, and t raised to half is m minus 1, that is 1 over 2 is m minus 1, and m is 3 by 2. So we can now write t raised to 3 by 2 minus 1, and here we have 1 plus t raised to 3. Now 3 is equal to m plus n, right? Because we want to, or we wish to write this integral in this form. So 3 can be replaced by m plus n. M is 3 by 2 and n is 3 by 2. And here we have dt. So 3 by 2 minus 1 is half, and 3 by 2 plus 3 by 2 is equal to 3. So now we have 1 over 3 root 3, and this integral is our beta function. So we can write beta m comma n, and m is 3 by 2 and n is also 3 by 2. Now let us find out the value of this expression. So for finding out this the value of this beta function, we'll use this result, that is beta m comma n is given by gamma m multiplied with gamma n divided by the sum of m plus n, that is gamma m plus n, right? So here we can now write 1 over 3 root 3, and then we have gamma 3 by 2, gamma 3 by 2, and in the denominator we have gamma 3 by 2 plus 3 by 2, right? So now I is equal to 1 over 3 root 3, gamma 3 by 2 square, because here both these terms are equal, and in the denominator we have gamma 3 plus 3 6 6 over 2, is 3, right? Now gamma 3 by 2 is equal to half times square root of pi, right? And gamma 3 can be written as 2 factorial, that is 2 times 1 is equal to 2. So here we have used this result, that is gamma n plus 1 is equal to n factorial, right? So here we have gamma 3. So gamma 3 can be written as 2 plus 1, that is equal to 2 factorial, that is 2, right? And gamma 3 by 2 is equal to half times square root of pi. So we can now write 1 over 3 root 3, and here we have 1 over 2 root pi square, and gamma 3 is equal to 2. So now I is equal to 1 over 3 root 3, and here we have 1 over 4 pi, and here we have 2. So simplifying this, we have pi over 4 times 2 is 8, 8 times 3 is 24. So we have 24 root 3. So the value of this integral is given by pi over 24 times square root of 3. Hello viewers, in today's session we are going to discuss another important problem from integration, and in this session we are going to discuss this integral where we have minus infinity to infinity x raised to 4 divided by 1 plus x square raised to power 5, right? So here we'll see how we can evaluate this integral using some properties of definite integrals, and using the concept of beta and gamma functions. So let us start. So let us first call this integral as I, right? So here, first of all, we are going to use this important property of definite integrals, where the integrand is an even function, right? Suppose we have the integral, say, from minus a to a, and here we have f of x dx, then this integral is equal to 2 times the integral from 0 to a and f of x dx, provided this integrand, that is f of x, is an even function, right? So by definition of even function, we know that f of minus x should be equal to f of x. So this is the first property which we are going to use to write this integral I as 2 times 0 to infinity and x raised to 4 over 1 plus x square raised to 5 dx, because here the integrand is x raised to 4 over 1 plus x square raised to 5, and we can see that the integrand is an even function, because if we replace x by minus x in this function, then f of minus x is now equal to minus x raised to 4, and then we have 1 plus minus x square raised to 5, right? Now here we have minus x raised to 4, that is minus 1 square, that is minus 1 raised to 4 is plus 1. So we have simply x raised to 4 and minus 1 square is equal to plus 1. So here we have simply x square. So we have 1 plus x square raised to 5, and this is our function f of x. So f of minus x is equal to f of x, which suggests that the integrand is an even function, right? So the first step is to write this integral in this form. So now our next step is to convert this integral into a beta function, right? And here we are going to use these important results, that is the beta function, that is beta m comma n is defined by this integral, that is 0 to infinity, and we have t raised to m minus 1 over 1 plus t raised to m plus n dt. So this is the definition of beta function, right? And moreover here will also utilize this important result which connects the beta function and the gamma function, that is beta m comma n is given by gamma m gamma n divided by gamma m plus n, right? And will also make use of this result, that is gamma n plus 1 is equal to n factorial, and gamma n plus 1 is equal to n gamma n, right? So these are some important results from the theory of beta and gamma functions which are going to be used to solve this integral. And moreover here m and n are greater than 0, right? Okay, now let us once again come to this integral, and now we'll make use of the method of integration by substitution, right? So let us take x square is equal to some variable, say t. So here it is important to note that we'll make this substitution x square is equal to t, because then we'll have 1 plus t raised to 5, and here we have 1 plus t raised to m plus n, right? So x square is equal to t, which implies that x is equal to square root of t. Now let us differentiate x with respect to t. So dx over dt is equal to d by dt of square root of t, and the derivative of square root of t with respect to t is 1 over 2 times square root of t, right? So now we can write dx is equal to dt over 2 times square root of t. Now let us change the limits of integration, right? So here x varies from 0 to infinity, and in the original integral we have minus infinity to infinity, and we have changed this integral to this form by using this property. So here we have minus a to a, here we have minus infinity to infinity, right? So now when x is equal to 0, then the value of t can be calculated from this relation. So we have t is equal to 0 square, that is equal to 0. And when x is tending to infinity, then obviously t is equal to infinity square, that is t also tends to infinity. So now let us write this integral in terms of t. So we have I, and this is 2, and then we have 0 to infinity, the limits remains the same, and x raised to 4, x raised to 4 can be written as t square, and then we have 1 plus t raised to 5, and for dx we can write 1 over dt over 2 times square root of t. So now we can easily observe that this 2 and this 2 get cancelled, and we have 0 to infinity. Then we have here t square, and here we have t raised to half, right? So taking t raised to half to the numerator and applying the laws of exponents, so we have 2 minus half, and here we have in the denominator 1 plus t raised to 5, and here we have dt. So now this integral I is equal to 0 to infinity, and we have t raised to 2 minus half is 3 over 2, and we have 1 plus t raised to 5, and here we have dt. So now this integral is transformed into this one, and now this integral looks similar to this one, right? So if we compare this integral with this one, that is say 0 to infinity, and we have t raised to m minus 1 over 1 plus t raised to m plus n dt, then m minus 1 is equal to 3 by 2, and m plus n is equal to 5, right? So we have here two equations, and we can find out the values of m and n, and m is 3 by 2 plus 1, that is 5 over 2, and from here we can find out the value of n, that is 5 minus m. So we have 5 minus 5 by 2, that is 5 over 2, that is 2 times 5 is 10, 10 minus 5 is 5, that is 5 over 2. So now this integral I can now be written as 0 to infinity, and we have t raised to m minus 1. So m is 5 by 2. So here we can write 5 by 2 minus 1, and 1 plus t raised to m plus n. So m is 5 over 2, and n is also equal to 5 over 2, and here we have dt. So now the value of m is 5 by 2, and n is equal to 5 by 2, and by the definition of beta function, we have this integral I is equal to beta function, that is beta 5 by 2 comma 5 by 2. So let us find out the value of this expression, that is this beta function, by using this result. So now we can write I is equal to gamma 5 by 2. Then we have gamma 5 by 2, taking m is equal to 5 by 2 and n is equal to 5 by 2 in this expression. We have gamma 5 by 2 plus 5 by 2. So here we have gamma 5 by 2 square, and then here we have gamma of 5, because 5 plus 5 is 10, 10 over 2 is 5, right? So now let us find out the value of gamma of 5 by 2 using this relation. So we can now write gamma 3 by 2 plus 1. We can split 5 by 2 like this, and using this result, that is gamma n plus 1 is equal to n times gamma n. So we have 3 by 2 gamma 3 by 2, and again splitting 3 by 2 as half plus 1. So we have 3 by 2, and again using this result over here, so we have half gamma half, and gamma half is equal to square root of pi, right? So we have 3 over 4, and here we have square root of pi, and gamma 5 can be obtained by using this result. We can write gamma 5 as 4 plus 1, that is equal to 4 factorial, right? And 4 factorial is 4 times 3 times 2 times 1, that is equal to 24. So now the value of the integral I is equal to square of gamma 5 by 2, and we have 3 over 4 root pi, and here we have square, and gamma 5 is equal to 24. So this is 3 square is 9, 4 square is 16, and the square of root pi is simply pi, and in the denominator we have 24. So we can now here cancel this 9 and 24 by 3. So we have here 8. So this is 3 pi over 16 times 8, that is 3 pi over 128, right? So viewers, the value of this integral I is equal to 3 pi divided by 128.